First thing we're going to notice, it is autonomous because I only have n's over here, and n is my dependent variable at the moment. If it's autonomous, we automatically know that it's separable. We're going to go ahead and separate this by moving all of the terms with n over to the left-hand side and multiplying by a dt to the right. So I'm going to end up with 1 over n times 1 minus n over 10 dn is equal to 3 dt. Now that we've got it separated, we can integrate both sides. Over here on the left-hand side, we can go ahead and think about this as is, but I'm going to choose to manipulate it with a little bit of algebra first before we find the antiderivative. And it's really that n over 10 piece. I'd rather not have fractions within my partial fractions if I can avoid it. There are two ways to handle that. One is to multiply the bottom, our denominator, by 10 and also multiply the numerator by 10. And I think that's probably the easiest choice. So if I multiply this by 10 over 10, I'm going to take that 10 and distribute it in to that part with parentheses. So on top I've got a 10, and in the denominator I'll now have n times 10 minus n. Now I can look at this and say algebra trigger a mixture of stuff. It's an algebra problem. It's a fraction, so I would check to see where my largest powers of n are. They're in the denominator, so now I'm asking myself, hey, did the bottom factor? Great, it's already factored for us. So time to do integration by partial fractions. Coming off to the side over here, I am looking at 10 over n times 10 minus n is equal to a over n plus b over 10 minus n. You work in our partial fractions magic. That means 10 should be equal to a times 10 minus n plus b times n. We do have two nice numbers that we can plug in. When n is 0, this will become 10 is equal to a times 10, or a is equal to 1. And when n is equal to 10, this will look like 10 is equal to 0 plus 10b, or b is equal to 1. Swinging that back over here, that means that instead of integrating that, I get to integrate this. So I've got 10 over n I don't know why I wrote a 10. We just found out that a was 1. My bad. 1 over n plus 1 over 10 minus n dn. And somewhere along the way, I lost my right-hand side. So let's go back and fix that. Well, if I integrate 3 dt, I'll get 3t plus a constant. And now, integrating over here, 1 over n, that's going to become ln natural log of n. Integrating this, I will have a negative ln of 10 minus n. We're going to take one more step to simplify this here and combine these two natural logs. So if I combine those together, that subtraction means I'll have division inside. So this is going to look like natural log of n over 10 minus n is equal to 3t plus c. I'm not going to fully do all of the algebra to rearrange this to solve for n, but I will at least take one more step, which is I'm going to raise both sides as e to the stuff so that I can go from here to n over 10 minus n is equal to e to the 3t plus c. This is a very common thing that mathematicians will play around with, to say that that plus c, because we're adding in the exponent, that really came from something that might have looked like e to the 3t times e to the c, and e to the c is just another constant. These aren't the same c, so we could call that a c1, and then say e to the c1, we're going to let that be equal to c. The other thing that we want to be able to deal with is that absolute value. Here I'm going to rely on my initial condition. So when t is 0, we know that n is 8. So if I think about plugging in 8 for n, would this term inside be positive or negative? Well, 8 over 10 minus 8 is a positive number, which means the absolute value wouldn't be doing anything, and we can drop it. Now, we might as well solve for that c because we have that initial condition. This says t equals 0, n equals 8. So plugging in 8 for n, I'll have 8 over 10 minus 8 is equal to c e to the 0. Well, e to the 0 is 1. 10 minus 8 is 2. 8 over 2 is 4. So it looks like 4 is equal to c. And we can take that and plug it back in. So I'd have n over 10 minus n is equal to 4e to the 3t.